Hello again. Welcome. Today we're talking about control flow. Control flow in Swift. What is control flow? Control flow is executing different branches of code or repeating blocks of code in the case of loops, for example. So you want to repeat a block of code multiple times. A loop is an excellent choice. And also we'll look at different control flow structures in Swift. So first, let's go ahead and create an array of some objects. Here we'll say let names equal to some literal array. And here we'll create some names. Sarah. And we'll also create Bob. And we'll create Tom. Okay. So here we'll use a for loop to iterate or to go through each element. Currently we have 4 names in this list. So how can we go through each element in this particular names array? So we'll use a for loop for this. So we start a for loop by the keyword for. Name is a variable, or sorry, in our case here, it's a constant because we won't be able to change name. So for name in, the in keyword is used with the for loop. It's a for in loop. So for name in names array, open curly, close curly bracket. So for name in names, and name here, if we option click on name, name is a string. If we option click on names, names is an array of names or strings. Okay. So here we have access to each individual name. So the first name will be Alex, second name, Sarah, third name, Bob, fourth name, Tom. So now we have access to name inside of our block, inside of our trailing in our curly bracket. Now I could go ahead and say print name and run my code. So now I'll see Alex got printed, Sarah, Bob, and Tom. So this is the for in loop. It's used to iterate over a collection, in our case, an array collection. We could also use the for loop to iterate through a dictionary. So if I create a dictionary here of, let's just create names or phone book. So here we have a phone book, and our phone book is names. We have dictionary like that, and we map it to phone numbers. So here we have a phone number. Sarah also has some sort of phone number. And we have Kim has some phone number here. Okay, so here if we option click on phone book is a dictionary where the key is a string and the value is an integer. So here we have a dictionary. How can we use a for loop to go through the key value pairs? So we start off with the for keyword again. So we'll say for. This time we will use an open parens to get access to both the key and the dictionary as a tuple. So here we'll say for, we could say key value in phone book. So the key, if we option click on key, key will be a string. If I option click on value, value will be an integer. Or we could also say for name, it's up to us what we want to declare our constant name as. Name, and we could say phone number. Okay, and here if I print and I say, I use string interpolation, I say name, phone number is, and I say phone number, just like that. And I go ahead and run my code. And here we'll see Sarah phone number is this, Kim's, let's just say Kim's here. This is better. So Sarah's phone number is, Alex's phone number is, Kim's phone number is. Again, a dictionary is not a sorted collection. It's unordered, and an array is ordered. So it will always be Alex, Sarah, Bob, Tom. But as I keep running my code, my phone book will be different in the way it prints the order here. Next, let's go talk more about the for loop. Here we could use a range. We saw range earlier in our basic operators. So here I could use a for loop in some range. If I was told to go ahead and print numbers from 0 to 10, including 10, I would use a range here. I could say for I or for num in 0 including 10. So to include 10, you need to put 3 ellipses here, right? So this is going to go ahead and print all the numbers from 0 to 10. And I go ahead, I play my playgrounds, and here I get 0 up to 10, including 10. On the other hand, if I want to say go ahead and print numbers from 1, so numbers from 1 up to, not including 10, I would use a half open range. So here I have a half open range. The less than sign, it does not include 10. It includes 1 up to 9. This one includes 10, 3 ellipses, close range. So let's go ahead and print num. And here we'll see 1 to 9. Okay, 1 through 9. The next construct we have for iterating is a stride. So I could stride through a sequence of numbers. Let's see what that looks like. So here I could say, let's see, we'll say, what am I going to use here? I'll say for number in, actually not for number, what am I going to do here? Okay, let's say for I in stride, we're gonna do through first. So for I, so from 1, actually let's go from 10. From 10, let's go from 10 through 1, and we'll go backwards, -1, just like that. So what are we doing here? Let's just say for number here. So for number in stride, this is the stride. We're going through the sequence of numbers from 10 through 1. So that's going to include 1. And we'll just go ahead and print num. So here we have 10 including 1. We decrement by 1. We could easily say decrement by 3. And this will go from 10, decrement by 3, we get 7, decrement by 3, we get 4, decrement by 3, we get 1. So -3 each time. So it's up to us how we want to go up and down here. If I want to include 1, I would use the stride 2. So here I will say for num in stride, this time we're using 2 here. Let's go from 5 to 1. And we'll go by 1. That's okay. Or by -1. And we'll print num. And this time around, we'll see it goes from 5, 4, 3, 2. Does not include 1. Up to 1, don't include 1. Okay? That's what strides look like. Now we'll go into the while loop. So we just looked at the for loop. Now we'll go into the while loop. So the while loop is slightly different. So first we'll start off with a counter here. We'll say for count equal to, let's do a countdown. So count starts from 10 and we want to count down to 0. So I'll say while count is, say, greater than, while count is greater than, uh, let's do 0. Well, greater than or equal to 0. We want to come in here and we want to print count. Okay. Something that's different to the while loop versus, say, the for loop is here. If we go, we declared a variable count, starts at 10, and now we want to do a countdown. So this, basically, this is going to go from 10 to 9, also include 0, because it will still come in here if it's 0. But our intention here is not automatic. This won't automatically decrement 10. We need to explicitly, very similar to what we did here, we said we want to go from 5 to 1, we want to decrement by some number. In our for loop, we didn't have any decrementing or increment in here. It just happens automatically because the for loop knows about the sequence, it knows where it begins, where it ends. But in our while loop, this is different because here we have a beginning state of 10, for example, but we need to change 10 somehow. So every time we go ahead and we print the value of count, we need to tell the compiler, do you want to decrease that number? Do you want to increase that number? Because at some point you want to stop the while loop. Because if I run this code right now, I'll go into what's known as an infinite loop. So without, in our case, we want to decrement. So without decrementing, this will run infinitely. Right? It will just keep running until our playgrounds either crash or our app crashes, right? It will just keep running, keep printing. But at this point, we have to go ahead and decrement. So I'll say count minus equal 1. So it's going to start from 10. It will print 10. It will decrement 10. So 10 will now be 9. It will come back. It will decrement 9 to 8, and so on until it gets to 0. It will go up here. It will check, is 0 equal to 0? Yes, it is. It comes here. It prints 0. Decrements 0 to minus 1. It goes up here. Is minus 1 greater or equal to 0? No. So this is false. So when it's false, it will end the while loop. So let's go ahead and run our code here. And here we have 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And we are done. Other loops we have a repeat while. Here I'm in command line. Let's see. Actually, I'm in a playgrounds. Let's do repeat while. So repeat while is also a loop structure. We'll say repeat while, and here we'll create a variable saying is keep playing, and we'll assign keep playing to false. So here we'll say repeat. I'll put in a print statement. I will say currently playing, and I'll say while keep playing. So what does that code read? I have my keep playing variable here. It's assigned false. In my repeat while, it will come inside my repeat first. It will execute the print statement saying currently playing. Then after, it will go ahead and check, is this while statement true? What are we checking for? Is keep playing true? Keep playing is false, so it won't repeat. So basically the repeat while executes the code in the repeat at least once before checking the while. So it will execute, or it will print currently playing. Then it will go ahead and check, is my while statement true? If it's true, it will go back to the repeat. It will print again. So let's go ahead and run this code. And here you see we execute currently playing, it printed, and that's it. If we were to, again, have it true, it would just keep printing currently playing. But in our case, we just started false here. Okay, so this is the repeat while. Not used that heavily in iOS itself, but if you created like a command line application, like a game or such, the repeat while comes in very handy. Expecting input from the user enters some input and checks to see if the while statement is true and keeps playing the game. Okay. Let's go into conditional statements. So conditional statements, here we have an if statement. We've seen that before, but let's just go through it here. Let's go ahead and do, let's create var is Wednesday. So is Wednesday true? And we'll write an if statement. So if is Wednesday, we'll go ahead and print happy hump day. Okay. So the if statement just checks if this statement is true, go ahead and print happy hump day. If it's false, it won't print. It won't print at all. So let's go ahead and run this. So here it says happy hump day because is Wednesday is true. So it will go ahead and execute that statement. The if else, on the other hand, here we'll say we'll change Wednesday. So we'll say is Wednesday is now false. And I'll say if is Wednesday, go ahead and print happy hump day. And I'll say else. In other words, if it's false, go ahead and print um, not Wednesday. Okay. Now we'll go ahead and execute this in Playgrounds and we'll see not Wednesday because is Wednesday is false. So it won't execute this statement. Instead, it will go to the else statement and execute not Wednesday. Okay. Next, we'll take a look at the switch statement. So our switch statement, for example, let's go ahead and create some sort of string here. We'll say name equal to, or rather, let's do language. Language equal to Swift, like that. And we'll say switch language. So I'm switching on language and I'm saying case, if it's Swift, go ahead and print iOS is awesome. And here, if it's not Swift, we'll use a default statement and we'll print just another language. And we'll go ahead and run this. So here we have iOS is awesome, right? Because our language is Swift. So the switch statement is a bit similar to our if else, but with our if else, we could easily fall into many if else statements, but the switch statement makes for more readable code and more concise coding. So we could have different cases, like I could have a next case in here saying case Android. I could print Java or Kotlin. So if I change my language here to Android, or rather, that's fine. Language is Java, and here let's do Java, and say, are you an Android developer? Like that. And now let's run this. So here it was going to print, are you an Android developer? Because our language now is Java. It won't print iOS is awesome because it's not Java. It will go to Java. It will find this match and it will go ahead and execute the statement. If it's not any of those languages, in other words, let's just put in Perl here. It will go ahead and execute our just another language because it is not Swift, it is not Java, it's just another language. Okay. Next, we could take a look at tuples on, switches. So here I'll create a tuple. I will say coordinate. So coordinate is a tuple. Here we have a coordinate. We have say 40 and we have 74. Okay, so we have a lat and long as a tuple. If I option click on my coordinate, it's a tuple. A tuple is a parents followed by your data types. So we have two integers in our tuple. And now I want to switch on my tuple. So I could use a switch statement here on coordinate. Again, keep in mind coordinate is a tuple. It has two values. And now I could use my case statement. I could say case 40, 74, and I will print in the north, and I'll have a default statement, because here a default statement is required, because now our why is it required? Because the switch must be exhaustive. What does that mean? I could infinitely have values here that satisfies my switch statement. I could have 41 mapped to 80. I could have 0 mapped to 0. The list is infinite. So if the list is infinite, your switch statement must have a default statement. It must have a default statement. So in that case, I'll just say default print not a valid, or yeah, we'll just say not a valid coordinate for now. And if I run this, it will say in the north, because it perfectly matches 40 mapped to 74. Okay. If I have 75 here and I run my code, it will say not a valid coordinate because it doesn't match my 40, 75 perfectly. Okay. All right. Other things you could do here, I could also use a case on, I could ignore, actually I could take in 40 and I could ignore my second tuple by using an underscore. So now it will just match 40. If it finds 40, it will just go ahead and print or execute that statement. So here I will say in the north, or let's just say lat is 40. And go ahead and run this code. So here we'll see lat is 40 because it doesn't match here. It doesn't match 40, 75, clearly here. It finds 40. It is a match. We ignore the second value, which is 74. So the only value it's looking for right now is 40, which is a match. So it will just go ahead and print lat is 40. Bindings now. So in value bindings, for example, if we were to take this particular example we wrote earlier, and how does value bindings work? So if, for example, I could say let long here, and I could use string interpolation to say in north, and I could write longitude is whatever my longitude is. In that case, our longitude currently is 74. So if we do get here, which we will get to line 110, let me just go ahead and print this. So here we see in the north, longitude is 74, right here. So this is known as value binding. So I'm expecting a value here. I could bind a value to some constant and now have access to the constant in this string interpolation here. Okay. Let's go on to talk about the where clause. Let's actually create a different constant. Let's create a number 10. And let's go ahead and switch on number. And here we'll say case, case 0, or rather case 10 for now. Case 10, print value is 10. And we'll have our default statement. We'll simply print not a valid input. So we have a number here, and currently we are looking at using the where clause. So I could basically put in a statement here, say, for example, where number is less than 20, for example. And actually this should be here like that. So where number is less than 20. What do we want to do here? We'll first check to see if case is 10, and we could say where number, actually let's do this, where number is even. Okay, so first check to see if it's 10, and also check to see if the number is even. And here we'll say number value is 10 and even, for example. So now I'll run my code again, and we'll see value is 10 and even, because we could also use the where clause on a case itself. So here we're checking to see, is the number 10 and is it also even? Okay, so you could basically compound the statements together with a where clause, right? So you could expand on the case itself to search or have a predicate on the actual number. So let's continue on. Compound cases. What does that look like? Here we will we'll switch on, let's create a character, and our character is A. And we'll switch on our character, and we'll say case. Here we could have compound cases. We could say A, we could say B, and I'll write a print statement saying found character. And let's close out our switch statement. We need to exhaust this switch statement by having a default. And I'll say not the character we are looking for. And I will go ahead and run. So here it says found character because the character is A or B. I could have a character C. In that case, it's not the character we're looking for. Not the character we're looking for. But I could also have a next case here saying C or D or S, doesn't really matter. And here I'll say print found the character. And if I run this particular switch statement, now it will print found the character, because the character C or the string C, because remember, we have to use string interpolation if we want this to be a character. We'll have to use string interpolation, or currently the compiler will infer this to be a string. Okay, so just keep that in mind. If you want this to be a character, you have to explicitly mark it as a character. Okay, so here we are. If I run my code again, nothing has changed. The character should still be found. So found the character. Okay, awesome. Let's go on to talking about control transfer statements. We have continue, we have break, we have fall through, return, throw. labeled statements. So let's go ahead and talk about what that looks like. So I'll have a for loop here for, let's just say number in, let's create a range. So 1 to 10, and we'll say if number is even, basically, by using the mod operator. So if this number is even, go ahead and continue. Otherwise, print the number. And let's see what happens from this code. So if I run my code, it will print only our odd numbers, because what happens is it first checks to see if the number is even. If the number is even, it will continue. It won't come to our print statement. It will simply continue to the next number, okay? So it first comes at 1. 1 is odd, so it will print 1. It will come across 2. 2 is even. It will continue to 3, and it will print 3 here, okay? So the continue basically continues to the next element, right? So it totally skips our print statement. It just continues to the next integer in that case. What does break do? If we have the same for loop, we say for number, and here we'll say if the number is even, let's do the same even here. This time it's going to be different. So if the number is even, we want to break. And if not, we will print the number. So the first number will be 1. It's not even, so it will print 1. Next number is going to be 2. It's even, is going to stop execution basically. So let's see what that looks like. Okay, so here we have 1 printed out because 1 is not even. It goes to 2. 2 is even. And at this point, it breaks out of the for loop. So what does this break do? It exits the for loop. It exits the for loop. Basically, it stops execution, right? Stops execution of the for loop. Okay, awesome. So this is what the break statement does. It breaks out of the for loop. In that case, it just stops execution as opposed to the continue. It continues to the next element. Let's see what fall through does. And fall through is best seen in a switch statement. So here we'll have, let us go ahead and do a grade. The student got some grade, let's say 85. We'll switch on grade. And here we'll say case, we'll say case 75 or case 65, or rather case 0 to 65. We'll just print C. We'll say case 66 to say 75. We'll say print. Let's give this grade a D here and give this grade a C here. And next we will go ahead and say case 76 to 85. We'll print B. We'll say case here we'll say case 86 to 90. We'll just say print B plus. And lastly, we'll just say default missing a letter grade. Or rather, we'll just say all grades entered, or rather, have a good semester, have a good holiday. Have a good holiday, just like that. And here we could put in a fall through and go over what that looks like. So if I run my code, currently we have 85, let's up that up to 87. And run our playgrounds. So here we'll see it printed out B plus. The fall through keyword basically will go to the next statement. So it won't stop execution. If I comment this code out, it will stop execution. It won't print out have a good holiday, for example. If I run my code again, it will simply print out B plus. But if I also want to execute the following statement, I could use a fall through, basically fall through to the next statement. In that case, fall through to the default and also print out the default. If I put a fall through anywhere else, let's see what that does. If I put a fall through here and I change my grade to say 60, anything between 66, 67, I could make it 66, just like that, and run my code. Let's see what that does. So it's going to basically fall through, print out my C grade, print out my B grade as well. Okay. So again, fall through the next statement and also execute it. So that person got a C and a B, which doesn't add up. But if you want to use the fall through to go to a next statement, this is basically what you could do. In our case, we want to just use it here and say B plus, have a good holiday, just like that. And we will run the code again. And we'll see, let's run the code here. Stop, run my code again. Oh, sorry, I gotta change my grade. Let's get a 89. Okay, so B plus, have a good holiday. Okay, again, fall through just goes to the next statement. Let's take a look at return. Return here is using a function. So we need to go ahead and write a function. I know we haven't gone over functions yet. We will get through functions, but basically a function encapsulates a block of code. So here I could write a function and let us go ahead and say function. Actually, let's do two things here. Let's do the function. Let's take care of an early exit and then using a guard and also using a return. So those two things we'll take care of using a function. So we write a function. We'll call the function add numbers. Add numbers, basically we're taking an array of numbers. It will take in an array of numbers, an array of ints or integers, and returns an int. And here we will have our array of numbers, like that, and we expect back some results. So we'll say let result from our function add numbers. Add numbers takes in an array of numbers, and we'll print out our array of numbers. All right, so let's go ahead and execute our function. So we'll use a guard statement. So if our array is empty, so if numbers dot is empty, what do we want to do is simply return, in our case, we'll just return 0 because we are calculating add numbers. And here we'll say if array is not empty, continue, otherwise return 0. If it's not empty, simply go ahead and get the results. So we'll say results equal to numbers dot reduce. We'll come into higher order functions, but for now, this reduce function basically takes in a closure. So here we could say start with 0 and add everything in that array and return results. So here, if my array is empty, let me first annotate my array like that. And if my array is empty, let's see what happens. So indeed, it returns an empty array, or rather, did I print out? I passed an array here, it returns 0. Sorry, I need to print out result, not array. So if I run this again, I should get 0, not my empty array. Okay, so here we get 0 because what happens, it gets to the function, our guard statement, early exit, this is what we have here. So it's going to basically not go through this entire function, but if the array is empty, it will basically return 0, okay? So this is why we got 0 printed here. We check to see if our array is empty. If it is empty, return 0. And basically here we're just using the reduce function. What does the reduce function do? It basically combines all the elements in a collection. We start off with a default value of 0 because we start counting from 0. And if there is values, we'll just add those values to 0 basically. So if there's 1, I add 1 to 0, you get 1, and we'll just keep adding. And then how we keep adding, we pass in this add closure. Okay, cool. And we return results. But if we do have results, or if we do have elements in our array here, we'll get back a result because in that case, it's not empty anymore. My array is not empty. So it will get to adding my numbers together, and here we'll get back 17. Okay, so here we took a look at the return statement, which exits the function. So return here exits the function, and the guard here basically guards or protects against the array being empty. If it is empty, it just returns 0. Throw basically is a way to throw an error. For now, we will not take a look at throwing errors. We'll take a look at that later when we talk about error handling. But for now, we'll just take a look at labeled statements and see what that means. So label statements here, I could have a for loop, for example, for num in 0 to, let's say, 10. And we'll have an next for loop here. We'll say for j in 0 to 10, like that. And we'll basically say if j equal to 4, what do we want to do? We want to basically, if j is equal to 4, we want to basically continue. We want to continue to this for loop here. So how can we continue to this for loop? Basically we could write continue. If I say continue here, it will continue to this particular for loop. But if I want to continue to this outside for loop, I need to say continue to this outside for loop. But how can I do this? So currently, if we run the code, let's actually print out, let's print out some values. So in our if statement here, we'll print out, actually, let's just print both values out here. We'll say print num and j, or rather I, let's just call them I and j. Print out I and j, okay? Run this. We could probably even make the numbers smaller. Okay, so when I is 4, we continue to our inner for loop. So let's see what's going on. So I is the first element. In that case, I is 4. Oh, sorry, j. When j is 4, continue. So when j is 4 here, continue to the next number. Actually, let us do this a little better. If this is equal to 4, continue, otherwise we want to print. Let's do that instead. So if j is 4, yeah, let's run this. And maybe make this smaller so we have less to view in the debugger, in the console. So run this. Okay, so we're looking out for j. So if j is 4, which is the second value, there we go. If j is 4, it's not going to print j, it's just going to skip and go to 5. So if j is 4, it goes to 5. If j is 4, it goes to 5, right? So if we want to skip the entire inner for loop and just go to the next value in our on our I, for example, how do we do that? So how do we go, instead of going to 2, 5, just go to 3 directly, right? So skip 5 and go directly to 3, for example. How can we do that? If I want to continue to this outside for loop, I could use what's known as a labeled statement. So I could use outer loop, for example, and continue here to outer loop. So again, the continue here will continue to my inner for loop. But if I want to continue to my outer for loop, I would have to use a labeled statement. So let's see what that looks like. So at the end of the day, we want if j is 4 to continue to the outer for loop, which will go directly to 3, 0, not to 5. Okay, let's go ahead and run that. So if we go back to 2, 3, as expected, it continues to our outer for loop. So instead of going to the next value in our inner for loop, it skips, it continues to the next value in our outside for loop. So it doesn't go to 2, 5, it goes to 3, 0. Okay, so if you want to continue to not the inner for loop, the outer for loop, you have to use a labeled statement. Okay, I did say that we will come back to throw, but for now, let's just take a look at what throw is. A bit more advanced from where we are currently, but in an example of as you go further into iOS, for example, if you have an error, we'll come to enums, but if you have an enum here and you have a way to handle errors, for example, let's just do, yeah, app error is fine. App error is some type of error that, and here we'll just say case bad request, for example. So we actually will throw an error. And now we have a function fetch data, and we'll say basically if, let's just do, so you have a function fetch data, and if you want to, in our case, throw an error, I could literally just throw an error right now. Say throw app error dot bad request. So if I call my function fetch data, I need to mark my function throws, sorry. Again, that was a bit of a more advanced topic, but just want to show what throws is and what it does. In our case here, we have no error. Let me actually write the whole error block. Again, this is a bit more advanced, but that's fine. We'll wrap this in a do catch here to catch any errors, and we'll actually just print out the error. This is going to be better for us to see visually what's going on. So I try to fetch, and if I do have an error, I will just print out the error. Let's try again. Okay, so there we are. Again, this is just for illustration purposes to show what throw is. And this is where we use throw, but along the way we use many other structures, which we'll go through later in more modules. But for now, if you have an error in a function and that particular request throws an error, you mark it with throws. The function is marked with throw. We'll come into that when we talk about functions. But now the actual place I'm using this function is here on line 216. So I'm trying to fetch data. If there is an error, it will get thrown in this catch block. And here I'm simply just printing what the error is. In our case, the error is a bad request. So it just prints bad request here, okay? But again, this is more of an advanced control flow structure, but just wanted to talk about it here. We'll see it more as we go deeper into Swift and iOS. So today, what we did was take a look at several control flow mechanisms and looping structures. We started off with the for loop, for example. We could iterate through arrays. We could iterate through dictionaries. We took a look at close ranges, how to go through a close range sequence, including number 10. We were able to print that. We took a look at the half open range. We took a look at the stride, how to basically use a sequence to go backwards with some number that you decrement or increment based on your use case. We took a look at the while loop. The difference between the while and the for very immediately is we have to handle the decrementing or the incrementing ourselves, or we could fall into an infinite loop here, where the loop just continues until the app crashes. We also took a look at the repeat while, the difference between a repeat while and a while. The repeat block will get executed at least once, and then the while will be checked for truthiness. If it is true, it will continue into the repeat again. We took a look at the if statement. So if some condition is true, it will get printed, the block will get printed. We took a look at the if else statement. If a condition is false, the else statement will get executed. We took a look at the switch statement, how you switch on different constructs. In our case, we're switching on a string. If it is that particular language, it will come into the print statement. If it's not, we have a default case, so it will just print just another language. We took a look at tuples and switches. Here we switched on a coordinate basically. And if it is this coordinate, we'll go ahead and print out the coordinate. In our case, we ignored the second value. So we just printed out lat is 40 because here we ignored the second value. Then we went on to talking about value bindings, how you could bind a value. In that case, we bind in the second value to this constant ln. So in that case, if it is 40, it will just go ahead and print in the north. Longitude is whatever ln is. In that case, ln is 75. No, it is 74. So it will print out 74. Next, we took a look at the where clause. So here, I could also add a condition. So if case is 10 and the number is even, go ahead and print this value. Other things we took a look at, compound cases. So here I could have a character C, and I could basically have a compound set of characters that I'm looking for. So in that case, C is found in this case, C or S or X or whatever it is. In our case, it found C here. So it printed, found the character. Next, we took a look at control transfer statements. We first took a look at continue, where continue is basically saying if some condition is true, just continue to the next element, skip everything, basically just continue. Don't do any other execution after the continue statement. Next, we took a look at the break. Here, break exits the for loop. So the minute the condition is true, it just exits that for loop. The fall through, we took a look at that in the case of we want to also print out have a good holiday. So if my grade is a B plus, just go ahead and print B plus and also go to the next immediate statement, which is have a good holiday. We took a look at early exits using a guard. So if my array is empty here, just go ahead and return 0. Return will exit a function. In our case, we are returning an integer, so we have to return an integer here. Next, we took a look at the throw keyword, and basically throw has to do with error handling. We haven't gone too deep into error handling, but we will get into that as we build applications and go deeper into Swift. But just know that the throw keyword allows us to throw an error if something bad happened in our application. Lastly, we took a look at label statements. So here, if we have two for loops here, as we do have, we have an outer for loop and we have an inner for loop. If my condition is true and I want to continue not to my inner for loop, but to my outer for loop, how can I do that? Well, one way you could do it is create what's known as a label statement. Again, be very careful in using this. The code could get very hard to read in some places, so just be cautious in the way you use outer for loops, because this could be refactored um, to other ways that you could handle that code. So this is one way to do it, but there's several other ways to handle that. So with anything else in programming, just be careful as into what you're trying to do, what's your actual goal. Um, okay. So again, as always, thank you for watching and catch you in the next video.